Hi everyone, thank you for joining. So this is the seventh video on Einstein's special theory of relativity, and in this video we will look at the idea of something being simultaneous and how do we deal with something like that at the theory of a special theory of relativity. So first, the definition of simultaneity is that we have two events, E1 and E2, taking place at different positions. Let's call them x1 and x2. They take place at different position, but at the same time. In other words, t1 will equal to t2. Okay. But of course, then we have to identify, when we say at the same time, as measured in some reference frame. Yeah? In some reference frame. Okay, so these events are said to be simultaneous. Yeah, in that reference frame. So we have two physical events, and then they are taking place in different positions in space, but at the same time measured in some reference frame. As you know, that if you change your reference frame, the time might vary, time might change, right? So that's the definition of simultaneity in relativity. So to better understand this, because now we will look at the relativity of something being simultaneous. Yeah. So what we want to do, perhaps do a simple example. Let's solve a question, and then we will look into a paradox and resolve that paradox. Okay, so let me leave the definition here, right? So let's say that we have an experimenter. So let's draw an x-axis here. We have a person standing at the origin, O, and let's call this person S, right? And what happens is that this person, at t is equal to, let me draw t here, at t is equal to 3 microsecond, sees an explosion, which has taken place at, let me use green color, I'm going to color code it. So this is 600 meters. Right, and the light wave reaches this person at t is equal to 3 microseconds. When the same person sees another explosion, which is 1200 meters away, and the light reaches this person at t is equal to 5 microseconds. Yeah, and the question we want to answer now. We have this two different events taking place in two different points in space, and the times appear to be different as well. But we want to know whether this event is a simultaneous event or it is not a simultaneous event. If not, we want to know when the firecrackers exploded. Yeah. Right. Now, how do we test that? Well, we know the speed of light. Speed of light is 300 meters per microsecond, right? So that means, if you think about it, if this is 600 meters, that means light must have traveled 2 microseconds here, right? And since the person at the origin sees the event at t is equal to 3 microseconds, that means the event must have taken place when t is equal to 1 mu s, right? That's quite straightforward. Now let's look at the second one. Well, that was 1200 meters. So since light is traveling 300 per microsecond, so we times that by 4, you get 1200 meters. That means it took 4 microseconds for light to reach from 1200 meters to the origin, but the person observes that as t to be 5 microseconds. So that means that means t must have equal 1 microseconds here as well. As you can see, that these clocks were the same when these explosions took place. So therefore, we conclude that these events are simultaneous events. So that's what this definition is saying. It is saying that this is what a simultaneous event is, right? Okay. Okay, this was a very short video on simultaneous events. So what we do in the next video is we're going to look at a paradox about simultaneous events, and we will try to solve that paradox. Right? Thank you for joining, and I look forward to seeing you in my next video. Thank you.